And the recordings are live. So I would like to start with, I'm probably going to cough a bit during this lecture, so I apologize for that. It seems I'm getting the first cold for this year, so sorry for coughing or snoring. So, good morning. Submission of workshop 2, deadline today at 12. Then I will start sending the peer review emails, and the procedure will be as last time. You will get 2 projects to review, take a look at, and you will get some instructions also for what to look out for. And then you will send your reviews to your groups, and you will submit a form when you get your own reviews done. When you get your reviews back to you, so to speak. I also made a class diagram over the current state of the game, and it's quickly becomes quite messy. And this is also in a project where we have actually put some effort into the design, so you could probably realize that if you don't do anything at all, things will become very messy very quickly. So this also maybe points to the fact that to at least give such a diagram to another developer is maybe not the most productive thing you can do, because you can't really understand anything from it. So if you have the goal of understandability in your diagrams, you probably should focus on some aspects of the diagram, depending on what you want to explain to the new developer. It's probably not a good idea to show everything and in one huge diagram and just let them look at it, because looking at this does not really explain anything except that it's a lot of relationships between a lot of stuff. So if you have the goal of explaining how the dealer works, for example, you should focus on the dealer and maybe explain the dependencies and relationships from the dealer, and not have everything in one huge class diagram. On the other hand, to spot refactorings or things that are too messy, these kinds of diagrams are good, because then you can maybe spot things that you can change to remove some of the dependencies. So depending on what you want, you should of course adjust your level of detail in your diagrams. So if you're in a refactoring scenario, maybe we need a quite complete view over the system. I get a question here, is a sequence diagram better? A sequence diagram is better in the sense that it is focused on one aspect, one function, one scenario, or the overall picture, so to speak. So in a sequence diagram, per definition, you don't get everything. So a class diagram and a sequence diagram in collaboration, so to speak, is probably the best thing, because then you can explain what is actually happening in runtime and how does the static classes look also. So some more information. The end is near. The course is rapidly coming to an end. I hope to actually be done with the materials for the lectures hopefully today, at least tomorrow. So then we have a few lectures that are more or less open for us to use as we please. And my idea is that you come up with topics that we can take a look at, and we will take a look at them. So I have got a few suggestions so far that I think are good. We will take a look at the example examination questions. So we will go through the example questions in the examination. And take a look at what you should do and think about when you solve them, and especially maybe the last three are the most interesting, because the first ones are more or less making class and sequence diagrams based on code. That should not be such a great problem. We could take a look at one question there, but the other ones, where you do some refactoring and stuff, could be a little more interesting to take a look at. So if you have not already done so, take a look at the example questions and make a solution for them, and we will go through the solution hopefully tomorrow, maybe, if we get as far as I think we will get today. And the other suggestion I have got so far is also to take a look at some common design principles that you hear a lot about. The open-closed principle, the list of substitution principle, the dependency inversion principle, and the interface segregation principle. That are kind of basic principles for good software design. That are, maybe we had talked about them, but we have had a little bit of other names for them. So those are the suggestions I've got so far, and I've started a thread in the forum for topics, and now I've got a new suggestion here. So more detailed explanation about associations and dependencies in a class diagram. When exactly does it go from being a dependency to becoming the stronger association? Or if there are any rules useful to follow. Yeah, basically, if you have an attribute of a type, you have an association. That's it. So if you have an attribute of a type, you have an association to that type, and you don't add any more dependencies to the type after that. Association is kind of a stronger type of relationship. That's probably also why it's a full line and not a dashed line. So we will return to the, feel free to ask any questions, by the way, or if you have any suggestions, you can either tell it to me or post in the forum thread. So we will take a look at 3 more patterns today and continue a little bit with our dice game. Not the dice game, the blackjack game. And last time we used the strategy pattern to break out one of the rules we could see was a point of variation in the game, how to start the game. And we found at least 2 variations here: the American way of starting with a hidden card, or the European way of starting with all open cards for the dealer. And this is good because we can now compose the rules of the dealer rather than rely on inheritance. That was the first choice we selected. We did a European dealer, but then we realized, okay, if we add any more variations, any other type of variation, for example, when the game, who wins the game, or the rules for the dealer when he is supposed to take a card, then we would have an explosion of subclasses, and it would be unmanageable for us to implement that. Any questions on this strategy pattern or the code that we did? And if we take a look at the class diagram, that is maybe somewhat messy, as I said. It's not on that computer, it's on this computer. We have the interface here. We have the American strategy and the European way of starting the game. The dealer has an association because it has a member variable of the type iNewGameStrategy, and it's called m_start new game rule. And we can see that in the implementation here. So we have a member variable, an attribute of a type, then we have an association. And we don't add any more dependencies after that. So we can also see that the interface in turn has dependencies to the player and to the deck types, because in the implementation we have a deck type and a player type and a player type again for the dealer. So a question is, can an interface have an association? Can you have an association going from an interface to another type? Yes or no? Too early for questions maybe? And I get no from the chat here. And why is it no? Exactly. You can't have any attributes in the interface. You can't add data or attributes or anything in the interface. So you can't have an association from the interface. So if you see an interface that has an association, it is probably wrong. In our implementations, we also used the card type. If you remember, we got a card from the deck and we flipped it and showed it, and we put it in the dealer or in the player. So we have dependencies here from the implementations of this interface to the card class. And as you can see, a lot of stuff is dependent on the cards. I also added actually the enumerations for the card color and the card value, and those are actually just used from the view when printing, and in the deck, I think, for creating, and also actually in the I could have made a mistake here because I think it's from the player type actually. Let's take a look. Dealer, dealer, dealer. Yeah, I guess it should be from the player actually, because here we have the use these the value type here. So this should be from the player. Also, we have one really bad thing here is this score of 21 that is hard-coded in both the player and the dealer. Really bad. You should not have that. You should make a constant for that instead and put it in the player class. and use that. So, okay. If we have the scenario of adding more rule variations, I won't be doing that right now. This way of sending the rules into the dealer in this way and creating them from the outside. I think we created the rules in the main type here. Yeah, we did. Could be a bit troublesome, and possibly also the creation of the rules should maybe involve some logic. You could read from a file, for example, that tells you, okay, you should use these rules, and we could have different setting files for different variations of our game. So if we want to ship a new version of our software, we just change the settings file and then we have a new variation of the game. So that would be quite neat. But then we would need to add a lot of code here to read that file and parse the settings and create the object, so that would probably not be a good idea. And in this case, we should use another pattern that is called factory, and it deals with when you have complex logic or something else that is needed to create an object and you don't want to use the creator pattern. In our case, we could have added the creation of the rule here in the dealer, and we did that at first because that's probably what creator told us to do. If two objects collaborate closely and the dealer is the only one that uses the rules right now, then the dealer should be responsible for creating the rules also. But this kind of violated our idea of protecting the dealer from rule variations also, because if we add a concrete rule creation in the dealer, then it suddenly has knowledge of these implementations. So then you should use the factory pattern instead. And I hope the smartboard will play with me nicely today. So, who should create an object if creator isn't a good choice? And I should have been writing that in red, but anyway. So, and the solution is just to make up a new class, call it factory, and assign the responsibility of creating the objects to this new type. So let's add a factory pattern to our game, and we will also actually be able to encapsulate the rules further in the rules package. And this will also be a good point of adding other creation of other types of rules that we can imagine. So instead of doing this, we will just take this code. And you could imagine having this point of adding this file parsing or some other complex logic to decide what rule variation to create. And you can also imagine adding other functions like this in this type. So we have this point of, okay, this is where the rules are created. So let's try and compile. Oh, in the controller. Well, yeah. How did that disappear? Yeah. And one too much there. So I get a question, static or non-static methods in the factory. Any idea? What do you think? Probably not. Why? Yeah, exactly. Why would you ever want to do anything static? There are very, very few instances where you actually need to have something static. Static operations, I don't think are necessary almost at all. I can find examples of where you have static member variables, static attributes that are needed because all objects are supposed to share one common variable. But the use of static operations are really, really bad because they become instantly available to everything. Anyone can call them. You can't override them. They are hard-coded in your application. So if you would like to change the factory later on, then you need to change every place where you have used that factory because the type name is hard-coded into the application. And if you base your design on static operations, it becomes more of a functional program. It's like having global functions for everything. And that is not a good idea. There are some other drawbacks also. I can imagine, yeah?
How would you solve that then if there is something that you really want all over your application that you want access to?
Yeah. Send it as arguments to the places you need it. Because if you have these global stuffs going on everywhere, how is the developer of a functionality in your system to know what to use? If he gets arguments to the function that he's supposed to implement, okay, I'm supposed to use these objects to solve this problem. I can go directly to those types, take a look at them and understand them. If we have thousands of static classes with static operations, the developer needs to know everything. You get a function with no arguments. Okay, what am I supposed to do here? Then I need to learn the whole application to solve my problem. I need to look up every static function and see, okay, is this one suitable for my needs? I need to understand every function, and I have no point of starting my problem solving. So always send arguments. It is not a sign of a bad design that you send a lot of arguments to your functions. It becomes much more easy for the one who is supposed to implement the function if he has the arguments he needs to solve the problem. And there are some instances where static is possibly maybe needed, but those are really exceptions.
I was thinking more like application-wide, where you might need some kind of variable, or like, for example, let's say you need to know the root directory of your application. You might need that in several different classes of models and functions. You can have that as a constant or static somewhere. You can always access it.
Yeah, and you get dependencies to that variable also from all those places. So, but why not send it as an argument to the function instead?
From where?
From the start. You probably have some kind of main method or something like that where the application starts, and if everyone needs the root directory, all right, send the root directory to every function that you call them. So, no, but it's actually more to the point and more actually, okay, this is what you get. I don't need to know all these constants and stuff to work in my application. You can just imagine if you have several types of these constants a little bit spread out, and you come as a developer, okay, I need the root directory. Where do I find this? Oh, it's in this constant, in this file, somewhere. So you need to look through. Possibly it's documented somewhere, but you never know. So you need to look through the code, and you need to find the name of that constant instead of having it as an argument. Root directory. So please avoid global constants, avoid static operations. They are really exceptions. So I get a question here, what is the purpose of the factory pattern? Right now we are just creating the class in another place and return it. How does it look if we have several different rules? Yeah, I can agree with you that the purpose of the factory pattern in this example is becoming a little bit constructed, because we haven't really no complex logic here, we have no code. And it is really not that different from what we actually did when we created the rule in the main program. So I agree that the purpose of the factory class here is not that obvious or different from what we did. But if we have more rules, for example, if we have some kind of interface for the rules for who should win the game in different situations, for example, if we have the same score or something like that, we have now a good place of adding the creation of those objects also. So we could just imagine get and so on and so forth. So we don't have those right now, but if we are thinking a little bit ahead, this could be an obvious point of variation also, and we could add our other rules there as well. So, but I agree. Right now, it's not really that different from what we did before, and we need to instead of doing this, we need to create a factory here. And we need to send this to the dealer instead. And we need to ask the factory for the rule. Something like this, I think. Ooh. So we added the factory pattern, and that's a pattern you use when you have some kind of problem with the creator pattern. We don't want to use the creator pattern in for some reason, so we add a factory type instead to create the objects we need. And in this factory type, we can add more complex logic for the creation than what we have right now, of course, but we won't go into that because it's becomes a little bit just more code, so to speak, and not so much in the design. Questions? A really good discussion on the static the problem with static operations. I think it's a good thing to point out, and don't be afraid, as I said, to send arguments. It becomes easier for the developer to know what to do, and you get at least a little bit of automatic documentation, because you give arguments, you give them, they have a type, and you give them a name. So there you have some documentation that how to divide work between a DAO class and a factory. What is a DAO class then? What do you say?
Database access.
Okay, database access object. From the top of my head, I have no idea. The other question is dependency injection framework a glorified factory? More or less. Dependency injection is I don't have really a great deal of knowledge about the frameworks of dependency injection. But they build on this principle of, okay, we should send in arguments to the constructor of an object to parameterize that object with different implementations of something, so that we can add a testing hub stub, so to speak, for a class instead of a need to initialize the whole system. So you could add in our case, we could add a start new game test factory strategy that initializes the player and the dealer to specific cards that they should have, and we could check that the score of the dealer and player are correct, giving these assumptions. About the data access object, I don't really know from just seeing those names how to divide the work between a data access object class and a factory class. Getting some typing here in the chat, so we'll see if we have any clarification. If the factory can have a task of looking in a file to get information, there is no use of a specific data access object. Or can there be a reason to have both a factory and a data access object class? Well, I'm going to give you the generic answer of it depends on the situation. I could imagine that the factory is more of a starting point, and maybe you can have different strategies of creating your objects, maybe from a file or from a database, or have a default object or a test class that you need to be able to create in some instances. So the factory could be the top access point, the top layer, so to speak, in that design. To give some kind of answer that sounds good. Anyway, to return to our design, we can actually see here, both in this design and in the code we have this controller package, and we have the view package, and the view package uses the cards and the value and the color of the cards, and I think that is fine. However, the controller uses the player and the dealer, and this poses a problem in some ways that we could. I will just take up the code for the controller. So when we get to implement this code, we could do a lot of funky things here. So if you get this code as a developer, and you are supposed to add the hit functionality in the controller, and you start taking a look at it, and what's supposed to happen when you hit? Well, you're supposed to give the player a new card. Deal card, new, and you could just start implementing something here, because we have access to that function in the controller. So the question now becomes, should I use this hit player function, or should I add something of my own here? Sure, we could take a look at the architecture and find that, you should not add business rules into the user interface or in the controller or in the view. But in the heat of the moment, we have release in 10 minutes. Things are going to happen here if we are not careful. So this is a little bit like those static operations that we could have. I need to find all the static operations I'm supposed to use here. Really, really hard. But on the other hand, it's not a good idea to send a broad, huge interface, so to speak, to a type when I really only need a few functions. And we have this principle also in our architecture that we should find logical groupings of types, and we should try to isolate them from each other as much as possible. And in our case, we have the model, we have the view, and we have the controller. And we can see that we have a little bit of a problem here in the controller because it has access to the entirety of the model. And that's not a good thing. And there is, of course, a pattern for this also. That is called a facade. So the problem is, how can we protect the subsystem from unwanted changes, access, or dependencies? So, and the solution is to design a single point of contact to the subsystem, a facade. And this is an analogy to a building. You have a nice, good-looking facade, and inside of the house it can be really, really messy, but no one sees that because they all only see the nice facade. So, we will implement a facade to protect the subsystem of the model and make the implementation of the controller a little bit easier and not provide so much access. And also, I think we actually missed one thing in our rule interfaces. Now that we have encapsulated the creation of the rules in the factory, we can actually make the implementations private to the package. So they do not need to be public anymore. So we have further encapsulated. So no one outside of this package can create a rule strategy of these two types. And that's a good thing, because now developers on the outside does not need to care at all about the inside of the rules package. They have the factory. Okay, I can get my objects from there. What happens inside this package, I don't really know, and I don't really care. So, but I think it's time for a break now. I will just make sure this compiles. Yeah, everything seems to be fine. So after the break we will implement the facade and take a look at that and see what happens. It's a little bit of a big refactoring actually. So thinking about these things a little bit ahead of time instead of making a lot of implementation is probably a good idea. That if you have a big subsystem that you need to protect in some way, you should think about having these kinds of facades objects from the start. I think it's a good thing to do. But anyway, let's take a break, 15 minutes.